In assignment 2, your goal was to create a ETL process that does incremental loading. To do that, you needed to use stored procedures and views, and you had to be mindful of the different types of slow changing dimensions. We have two different types here. Type 0, in which case we just reloaded incrementally, that's the fact table. And type 2, which is we load the table incrementally, but we also track what is the current, what was past, and what is the in-between stages of the data using a type 2 slow change dimension. And that was kind of it. So to do that, I need some views. I need a view to fill up the data in dim products, a stored procedure that would synchronize the data from the source to the destination, and I do the same thing with dim customers and fact orders, same thing. So dim dates is different, it just runs and it fills it up. So we don't need to drop the foreign key constraints or truncate the tables or anything like that because, well, we're doing a synchronized loading. But I do need to go through and create my views. So I want to go through and I want to put my header in there. I want to write the code to test it. And I see I get this data here. Now I have 295 roles. If I were to go through and add on some other things, like let's say that I don't want, for some reason I don't want anything with 295 rows, anything with a list price of 0. Looks like I don't have anything in there, but I could put that in there in case we had something that did not have a price, so we don't think it's going to be sold just yet. I can also go through and do something like this, where I'm looking for a list of products from the sales order details, so we only bring into the data warehouse any products that actually sold. If they haven't actually sold, we don't even bother bringing them in. That could cut down on the size of the data you're trying to bring in the database, which is not a bad idea. Another thing we could do to cut down the data is we could go ahead and say if it doesn't have a subcategory, we could not bring that in if we thought that was important. Of course, we can take the subcategory and turn it to some other different number, but there are times where you want to kind of clear things out. You want to not include everything that you bring into everything in the source database. You don't necessarily want it in the destination database. Now, if I was doing a full join, then the subcategories that were null would still come over. If you don't do a full join, putting this in is going to help because the full join is going to filter it out anyway. And if you do use a full join, you're going to get parts that have no subcategory or actually list price. So if I were to do that, that would be an issue. And we can see, when we run this, that in some places we should have a null coming up. And if not, then it's because we lost it on one of these other filters. And there we go. So you can see that there's a bunch of data in here that we could bring over. But if you look at it closely, this data is actually components that make up things that we sell. The reason why this stuff is at 0 is because, well, we don't sell this individually. This is components of something we do sell. And as such, they don't have a subcategory. So we don't need to do a full join to get all the data over. We're not really worrying about those individual components. And as such, I don't really need this. So I check the data, I make sure that I'm getting what I want, I do the casting, I make sure that things are cast to my new format, whatever that new format is. I like to use column aliases. That's a very simple transformation, but it makes working with things a little bit easier. For one thing, my names of the columns match up with the columns in the destination database. I find that a useful mapping choice. When we do things like use other pieces of software, things will automatically be mapped in particular pieces of software based on the name. So that's also quite handy. So anyway, once I had this done, I'd go through and create my view. So create it. Oops, looks like I got a little extra carry there. And once the view is made, I just make sure that the view is working. And once that's done, I go through and create my stored procedure for the ETL process. Now, there's a couple ways you could do it. One way, of course, is to use the three different CTEs, where I go through and first of all, I look for an update. I want to change the end date and current date on any rows that might be added. So if there are rows that were in the database that haven't been added over here, they would show up, and I'd want to see those and bring those in. So this means to me that this database is probably filled, and that's not going to help me check it out until I go through and clean that out. So let me do that real fast. Homework assignment 2. Make sure that we get that data warehouse all cleared out for testing. Okay. Now, since I cleared out the data warehouse, I'm going to have to go back and do that view again too. Okay. Make sure it's working. This still fills up with data because we're getting data from the source database. And the stored procedure now should work. So when I run this, I should have rows in the original source database that just aren't in the destination database. At this point, you might have left off the isCurrent. But the thing is that the isCurrent will come in handy if it has already been marked as it is current in the original database. So this is important. If you ever change the value to something else and then you change it back to a previous value, you'll get a ghost. Otherwise, you'll have multiple items that are marked as current. You don't want that. So I want to put that in there. And then if I find something coming in that is a match for this, I want to update the database and say the end date is currently now, because we're trying to put in new data. So whatever is in there now needs to be flagged as end date, and is current is set to 0 because it's no longer the current record. And that's pretty much it. So once this thing runs, it will synchronize the data, and if we go look at that data, we would be able to see, whoops, that's not the place to look. I'd be over here. We'd be able to see the data warehouse should have data. Let's see here. Update. Oh, that's right. There's nothing to update. We're still doing the update. Let's go ahead and fill it up with some data. That's the insert right here. So once again, we're going to check to see what's in one and not in the other. Still want that -1 there, and then we actually do the insert. So this will copy the data over, and now I can come back over here and check this. Okay. And what we're trying to do is we're going to try to do an update. I want to change this price. So we're looking at AdventureWorks products table where the product is $680. The current list price is $1,431.50. And we're going to set the list price to 1 to make it, obvious that something has changed. So that was the original price, and when we do, we'll see that things are out of sync. Now when I look in DEM products, there's definitely a difference between things. For one thing, the price is just very, very different. Obviously, it's so we need to go through and do that update in order for it to work. So I'm going to run this code. It will flag it so that if I go back and I look at dim products again, you can see that the is current status is set to 0 and the end date is set to now. And that's because it's just about to insert the new data in. Now the only thing that's new would be this one row. And its current value, again, is set to 1 if I look at this. So if I look at this, and I look at for anything that's 1 right now, you really can't tell this, but it will be applied to the group. So when I go through and I run this, that's the one row that needs to be updated. So I go back here and I run this. It gets updated, and now if we look at that, we'll see 2 rows, and one is the new one that is set to is current that happened during the insert. And that is exactly how this is working. Now when I go back and I look at this with the is current option on here, oops, I keep forgetting the is current is associated with the top one. No, that should be right. Why am I only saying, oh, because they're all current, duh. So yes, all those are the current. So if I were to leave that off, I'd have one more 296, and with that it should be 295, and it is 295 because that one was set as being out. Okay, so now what I want to do is I want to set it back to the original value, and again, you always want to test for this. And if I look at AdventureWorks, it's back to what its original value was. Its new value is not represented yet in the data warehouse. But if I were to go through and look at the difference between the two, I might not see anything because its current value was a match between these. The only big difference between these, because everything else is the same, is that the is current marker is set at 1. So that's why we need to have this piece, because if you ever set it back to an original value, that would do it. So now this isn't a really great choice, but certainly I can see the price fluctuating back and forth and coming back to an earlier value. The example I used in the class during the lecture was that a person's changed their name a few times, first to one thing, then back to the other. That would also be an issue. So that's how we take care of the insert. And then on the update, all we have to do is switch these around. So we look at the data warehouse first, and then the original source. And if we find that, then what we do is we go through and just flag the row as now being no longer current, instead of actually deleting it. So once we test that, we would we'd actually go through and add a new row, delete the row, etc., and make sure this works. So I'll go through and create this. I should be able to execute that sprock, and it should synchronize it. And if we go through that testing phase, what I could do again was I could delete one of those rows. So if I delete, let's see, there's probably a foreign key constraint in there, so usually it's better to go through and test it by adding something and then removing something. Do I have a test page? I think I gave you guys a test page. Let me go take a look. Here's my fourth file. Come on, fourth file. There you go. So that's inserting in a customer. Here's inserting into a new product. Oops, got to be in the right database. And that's not it either. It goes into AdventureWorks Basic. Yeah. So now we got a new row, and we can come over and test it. And as always, you really need to kind of test as you go. Custom customers. Let's see. Where's dim products here? Here it is. Okay, that new row should not be in there. We're going to synchronize it. We should be able to see the new. The status information tells us that the store procedure was successful. If you get a positive number, it was successful. And our new value should be here somewhere, like right here at the bottom. So that's working. Now, what I do then is I'd go through and I test the update as well. So we test the insert. We can test the update, doing the same thing. Test the test update product where it said test insert product. And now when we go through and we synchronize it, we should be able to see that change has occurred. It should say test update, and it does. Now it also has a test insert, and it's got a 0 there because that is no longer a valid one. This one is the new valid one. And the same thing would go for deleting. We test delete there too. So, oops, wrong one. This one. We can see that's gone. And of course we go back over here. We synchronize this. And we go down to the bottom. It's still there. The problem is, it's still there, but the last row has been set to 0. So now since both of these products, same product, but they're both set to 0, it's no longer it's been deleted. It's no longer in the database. So that is how we would do this. That would be the first example, and then the next thing in the customers, same thing. Go through and make your select statement in the view. This one's a little bit easier. And then after that, you go through and do the same kind of thing. Now you could have used merge to like I did in the example. This is usually a simpler version for many people anyway. And I'd run through the same scenario. I'd go through and make sure that I can synchronize it. And then come back over here and test these. Make sure that they are indeed working. Now, I'll test them all kind of at once here. I think that's a better choice, so I'm going to go ahead and rebuild the database. But in real life, when I did this, I went through and I checked each one as I made it. And then for dim dates, that one's pretty easy. The only thing you had to do is you had to make sure that you were in the correct range. Now the correct range is going to be determined by the numbers that you test with. If you test when you go through and you write your test script, if you test a particular date that is kind of way out of whack, outside that range, it's not going to work. So I need to make sure that when I put the order date in, did I even have an order date here? I did not. No, it's get date. Yeah, I have to make sure that that is within the range. So obviously this is not going to work when I go to test it. That has to be changed over to a different number. So 2000 I think is probably too low. If I take a look at the data in the orders table, I don't believe that it ever dips down that low. We can go take a look at it, but I think that's right. So I'd come over here and I take a gander at the original database, looking for the date. So that's going to be in the sales header or order header. Order header. Just look at the top 1,000 rows. And we can see some. You should be able to see some dates. 2005. I guess I should order it by the date. Just be sure that's the second column. So order by 2. And this way we can see this is ascending, so this should be the lowest. So 2005 was all we really needed to have. And that means that we just have to change that. So in our script, we have to change this over to like 2005 to 2025, 10 years. When it runs, it should fill up the table with our data 2005 to 2025. That's good. And then the fact orders, you could do the same thing as before, but people have, so just make the view. The big thing here is most people try to do some kind of tricky join on the date table, but you really don't need to, because when we insert the data into the date table, we're using this format. So since I'm just converting the dates into this format in both the script above, where I go through and I create the date key, I just have to do the same thing down here in the fact table. That is one of the tricky part. And of course, getting the join to work is a little tricky, because you have to make sure you join on the IDs, not the keys. The other thing is, again, you want to add these values in, because otherwise, if you do an update, you'll have multiple rows. Just like I showed you a little earlier, multiple rows will exist. Some will be marked as 1, some will be marked as 0. When you want to add new rows into the sales table, you only want the stuff that is current. So current product, the current customer, that's the key that you want. And so that's what we want to link back to, because it's the key that it was when this thing was filled. Now later on, if we have a different key, a different product key or a different customer key, the link will show that historical change. So we would see, let's say the customer starts off at customer key 1, and then they change their name, so now it's customer key 5. When we run this and we add a new sales order, it'll be connected to customer key 5, because that's the current one for the customer. If they change your name to something else and they become customer 27, then when we get around to putting new data into the sales table, it will point to customer 27. So that will be the latest information there. Now the only downside, of course, is that when you fill this up the very first time, it'll only be the current customer. But you know, I can't think of any way to go back easily to go back historically from that. But once you're maintaining it going forward, it'll always have the current customer name or product name or whatever other data historically. So this is an important piece. Again, otherwise, when you do an update, you end up with multiple values, or you do an insert, you may have multiple values there, and it wouldn't get the correct one. So I go through and set that view up. And as I'd mentioned, you can use merge as well as the CTE option. The merge is a little bit more efficient. It can be a little busy to read, but it actually works just fine. So take a look at the source and target tables. The source is where we're getting our data from. I'm getting it through the view. I'm going to compare it to the fact sales orders table that's in the data warehouse, asking the question, what do you get combining these two? I don't think there will ever be a time where these values will ever change. The sales order ID isn't going to change. Maybe other things about the sales may change, but the sales order ID shouldn't, or detail ID should never change. The date key, I'm not actually taking that into account, but if I add it in there, say change the date or something like that, I could, let's see if this added. Yeah, it wouldn't have any impact on this. The thing that might change, they might change the customer or the product, but again, I really don't think that would be the case, because how often when you update this? Normally, if something goes really wrong, then you might update something, but let's say that you update to a different customer. When this thing fills, when this thing merges into the data, you would have to, it would only get the customer key that is associated with at the time that the fill happens, because it's going to look at that customer key. So it's not going to go back and change things based on this. If we ever find a time where the customer key in the target table doesn't match the customer key in the sales table, fact table, so in the target table it would be whatever we're driving through, that doesn't really come into play here. And that's coming from the source. If I look at that view, I see the customer keys here, but there's nothing in there right now, so doesn't have any impact on it. The column's there, and it will be captured. It will be captured in the joins for the view, but only if we have stuff in the other tables. So let's see, dim dates is filled. Dim customers, I don't think is filled yet. Yeah, let's fill it up. Uh-oh. Okay, that's the sprox. I still have to execute them before they fill. Okay. Big thing is keeping everything synchronized as you're going through the system. There we go. And let's see, that should now. Already did that. Okay, dim customers is filled up with data, and that dim dates is filled with data. So this query now should run, and we should get data. There we do. So now we have the customer key, the product key, and the date key. Again, these aren't really going to change as we reload things up. So it's not really going to help us to have those, because like, if you were to change that value, you would get another row in there. But in my design, I don't think that's ever really going to change. And I would expect that these would never change, the order IDs. They're either the order or they're not. If they aren't the order, then that doesn't matter, because it's a different order. Anyway, so if you find something in the source that's not in the target, you need to insert it. When they're not matched, you insert the data. The insert's pretty straightforward. If you do find them matched, then there's some other qualifications I want. First of all, I want to see if the quantities are matched, because that'd be one of the things I might update. Maybe they made a mistake. I would update the quantity. I wouldn't update the product, because it wouldn't make any sense. Wouldn't update the customer name. That wouldn't make any sense either. But if I was going to fix the order, I might say, oh, they're supposed to order, they really meant to order 100, not 10. So I might change that, or vice versa. The the actual price, that could change too. It's possible. And if it did, I'd want to make a note of that. And the order date key, again, it's not really a great option, because the order probably shouldn't actually change at all. But if they did, I could make a note of that, and to do that, I would just go through and do an update. And basically what I do is that the quantity and the price and the date would all change. Again, I don't believe this is a really great option, because the the sales order header value would change at that point. I seriously doubt that somebody's going to change the date that something had occurred. Now, if they don't match, in other words, you find something in the target table that has been removed from the source table, they've deleted an order of some type, I'm not tracking changes over time. I just delete it. So that's all I do here, I just delete it. Anyway, that's the sprox. So when I run this, I test it, I synchronize it, And then I just want to make sure it all works. So go through and run it. Status comes back. Uh-oh. Says something about the sync order factory. It's a invalid object name. Did I not run the code? Let me run the whole thing. It'll drop them all and run them all again. Yeah, I must not have run it. So these are all coming back with a status of 1. If I look at the data, I should see that it's all filled up. All the tables have their data. That's what I'm looking for. The next thing I do is I check to make sure again that I can make changes and test it. So I want to try inserting a customer, a product, a new order, and let's see. We're getting the product ID that we just inserted because I want to be able to insert the same one because of the foreign key constraint. If I don't do that, I could mess up the foreign key constraint. So now if I take a look at this, I should be able to see customer 1, customer 101, and where I'm getting these numbers are I inserted them myself. So customer 1, customer 101, 11,111, and the same thing here for 1, 2, 3 for the sales order ID. I just made up some stuff. So when I look at that, now it's time to go through and make some changes. So that's in the source database. I want to synchronize it. So I have to go back over here and make sure that it synchronizes. Let me run this. And if I go looking for that data at the bottom of each of those tables, I should find that. Let's see, test insert of products. Yes, that's good. And look at this one, all the way at the bottom. Test customer, good. And then look at this one. Actually, the date, I didn't do anything. So look at this one, and all the way at the bottom, I should see my new entry. And do I? Product key, what was the product key? Product key was, that's customer, 296. So am I seeing a 296? No, and if I'm not, that probably means that I need to order this. Order by 1. Oh, that's why I already ordered it. It's up the top. That way I didn't have to go digging for it like I just did. Okay. So that's working. The next thing I want to do is I want to make sure the update works. So I do the same thing. I do an update on all of this. I check to see if the update did take effect. I can say that this is the data. This is coming from the source database. And you can see the name has changed here for customer, etc. And I go back and I run my code again and just verify that it syncs correctly. If it works correctly, then when I look at this data here, I should be able to see in that first one, I guess I should put an order by on that one too. I should be able to see in that first one, his name has changed indeed, and you notice that it was the one above was the same thing, and the slow change dimension has tracked it. We saw that a little bit earlier. The product's going to have the same thing as the customer. And then dim dates didn't change. The fact sales table, or fact orders table, it's at the top. That did change. We moved it over to a different price, if I remember right. Let's go take a look. Let's see. We changed it. I guess we changed the price. Yeah, the price is there. Looks like we also changed the date just to prove it could be done, although I'm not a real big fan of that. So it does seem to be working. I got the new date, I've got the new price, etc. And the only one we have to test yet is the delete. and you can see that that row is gone. It's still in the original database though. If I come over and I run this, or the original database, the data warehouse database. So I come over and I run it, I can still see that it's there. Let's see. Yeah, I really should have put order by descending. So you can still see it's there in the data warehouse, but and it's still marked as being current. That's because I haven't synchronized yet, but that's about to change. It's synchronized, and now I'll come back over and take a look at it. We can see that it's been flagged as 0 and 0, and it's been deleted from the order because that's a type 0. We're not tracking any changes. Or type 0, type 1. So that's how you do it. Hopefully that makes some kind of sense. Now if you wanted to do like the products table with merge instead of the CTEs, which is more efficient, you could just change the code out for that. If you go back and look, you'll see that I provided this stored procedure in the demo. And this one actually does the same thing. Look at products, and if you find a difference, you, based on that, you just go through and do the insert, update, delete. So that's the exact same thing. I just have to go through and set that up. So it would be slightly different. Let me set that up, and I'll show it to you in a minute. Okay, so here's the completed version of the merge. The big difference between the original example I gave in the lecture was that there are additional columns here. Standard price, product standard price was added, product subcategory, and product subcategory name. Those items were added. The other thing that was different is that the status was as current was a numeric value instead of yes or no. So when I went through here, I had to alter that code and let's see, add on the standard price, the category, subcategory ID, and subcategory name. So those had to be added. The data type on the date was no longer an integer in this case. That was a gotcha. You had to convert it over to a date. That was in the dimension table, of course. And of course, as I said, the yes, no was now 1 and 0. So that had to be changed, and these values had to be changed. Now, normally I wouldn't put the subcategory, the standard price, subcategory, and product subcategory name and ID at the end. I put them up here, but I just want to keep it kind of clean to see where it's at. Of course, it doesn't really matter the order as long as you put them in the same order in the value section. And then down here, same thing. I just had to convert this over to a date instead of an integer value, and no into 0. After that, though, it works just fine. You just have to run it. So it was really the same code as before. It's just a matter of getting it, adding those additions on there. You execute the stored procedure, it runs. Of course, the real test would be going through and running it with after it's been cleaned out. So let's just go ahead and use that testing code. So what we're going to do is we're going to insert a new product. Sales order detail. We don't care about that. We just care about the new product. There it is. Okay. It goes in. We come back over and we test to see if it works. It says successful, but let's go take a look and see if we got a new row. And we got the new row. It's currently in here. It just came in. So yeah, that was in there. This was from earlier. Remember when we deleted that and it was flagged as 0. So this is indeed the new value. And of course, we should do the update as well. Make sure that's going to work too. So I'll go down here and do the update. Come back here and test my sprocket one more time. And come back over and take a look. We should now have that second row in there. And we do. So the old one and the new one. So yep, it's working. And of course the last one we test out is the delete. So I'll delete that new header now. Let's see, did that change? No, I'm using the name, so it makes it really easy. Okay. And it should be gone. And now if I come over here and run that code one more time, I should see that the product has changed. Still got the 4 rows, but now they're all zeros. So that's working. And customers would be the same thing. You just go through and look at your list of columns and make sure that your inserts match. Other than that, it's not too hard once you get your head wrapped around merge. But at first, many people find it more difficult. So that's how I tackled assignment 2. Of course, yours may be just slightly different, but in general, I think that most people came up with an answer very, very close to mine because there's not that many choices. And hopefully you found this useful. So thanks for watching, and I'll talk to you later.